Today we're going to talk about factoring by grouping. And again, we're going to look for the greatest common factor first, and then factor it out if there is one. The greatest common factor is going to stay out front and remain as part of your final answer, so you don't want to lose it. So we're going to look for the greatest common factor. Because there are four parts or four terms in this polynomial, what we're going to do is we are going to group them in pairs. So when I look at my first, I see that I have an 8x to the third power plus 2x squared. And I know that 2 will go into both. And this one has 2 x's, and that one would also have 2 x's. So I'm going to factor out 2x squared out of both. And now 2x squared times, 2 times 4 gives me 8. And then x squared, there was 1 left because we took 2 away. And so that means there's only 1 x left. So it would be 4x. And 2x squared is the same as 2x squared, so we're going to add 1 to that. Over here on this one, when I look at them, I also have a 12x and a 3, and I know 3 will go into 12 evenly, and 3 does not have an x, so I don't have to worry about a variable this time. So 3 times 4 gives me 12, and then bring down my x, and then because 3 is 3 plus 1. Now, do you see these two here? See those? They're exactly the same, aren't they? So I have my 4x plus 1 times my 2x squared plus 3. That was my greatest common factors. Okay? Now, if I were to use my FOIL method and multiply it all out, I would get 8x to the third power plus 2x squared plus 12x plus 3. And you can do that if you want to check your work to make sure you've got the right one. When I look at number 2, I have a 5x cubed plus 10x squared plus 2x plus 5. Again, I have 4. So I'm going to break them into 2 groups. When I look at 5 and 10, I know that 5 will go into both. And this one has an x squared and this one has an x cubed, so I know that I can use 2 of them, and that'll leave me with 1 remaining. Okay, so that would be x squared. 5 times 1 is 5. X squared times what's left. 5 times 2 is 10, and x squared is already being used. And then I have 2x plus 5, and it doesn't look like I have a greatest common factor. Because this does not have a greatest common factor, I could look to see if I change the sign, if that would work. And in this case, it does not. And if you go up here and look at step number 5, says if it does not match, see if you can make it match by changing the sign of what you factored out. And if you can't, there's no GCF. So there is no GCF for the whole thing. So when that happens, then what we do is we just write the word prime. It has no greatest common factor for the entire thing. Okay? There is another method that we can use. This is called the box method, and I hadn't seen this before this lesson, so this is new to me. It says step 1, factor out a GCF. If the leading coefficient is negative, factor out the negative number. And sometimes it has to be a -1. So keep that in mind, okay? So when I take a look at all of this, I can see that I can take a -4d, a -4d, a -4d, and a -4d. So when I take and look at all of that, I know I can take a -4d out of it. And so that's my greatest common factor. because 4 goes into 4, 8, 12, and 24. There's only one D in this one, so I can only take one D out of all of these. Because the leading coefficient is a negative, my greatest common factor is a negative 4D. So then I get negative 4D times, because I took one out, D to the third power becomes D to the second power. Or, sorry, that's fourth power. Third power. Negative 4 times negative 2, that's why it's a negative here. And when you take out a D, there was 3 before, now there's 2. If I take negative 4 into negative 12, I get positive 3. And because there were 2 D's and I took one out, there's only one remaining. And then negative 4 goes into 24, negative 6 times, and because I took the D away, there's no D's remaining. It's just negative 6. Now, I'm going to take this information and I'm going to put it in a box. So the first 2, I'm going to place in the top row, and the second 2, I'm going to place in the bottom row. And now I'm going to find the greatest common factor of these. So when I take and look at D to the third power and D to the second power, I see that I can take 2 D's out of each. Okay? And that leaves me with 1 D. Okay? And then I have a 3D and a negative 6, and I know that I can take a positive 3 out of both of those. So that's where my positive 3 comes in. And if I take the 3-way, and I already took 2 of those, so that's 1 D here. And then here I have, if I took these 2 D's away, and I have negative 6 and negative 6 and negative 2, that's going to give me, if I take 3 of those away, it gives me negative 2. Negative 6 divided by 3 is negative 2. So find your greatest common factor on the top row, and then write it on the outside of the row. Repeat step 3 for the bottom row and both columns. So that's what we did. Okay? Alright, so then that leaves me with D squared plus 3. That's here, D squared plus 3. And this one here is D minus 2. And that gives me the whole thing. So let's try it. Alright, so I see 6p to the fourth power plus 3p to the third power minus 24p squared minus 12p. So of all the numbers, I have a 6, 3, 24, and 12. And I know that 3 will go into each of those. So I'm going to use 3. And then the last one only has a p, but they all have p's. So I'm going to bring the p down. Now 3 times 2 is 6, and p times p to the third power, there's 3 left, plus 3 times 1 goes in. If I use 1p out of the 3, I only have p squared left. 3 times negative 8 is negative 24. And if I take 1p from the 2 p's, I have 1p left. And 3 times negative 4 is 12. And p times p, so there's no p on this one. So now let's draw our box. I have 2p to the third power plus p to the second power minus 8p minus 4. These each have 2 p's. So that means that's gone, and there's only 1 p left here. Okay? And now this one goes in, 4 goes into each. We actually could call it negative 4. And so then that's now 1. Then we have 2p goes into both, and that brings negative 2p, I believe. So then I get 3p times p squared minus 4 times negative 2p plus 1. There's our greatest common factor that we found at the beginning. And then what was left is here. Now, if you would like, you could go back to the way we did it before and break them into pieces. So we take our greatest common factor out, and we get this, and then divide them into two groups. So when you're looking at this one, d to the third power minus 2d to the second power, we're going to take d squared and get d minus 2. And over here, we can take 3 out, and that gives us d minus 2. And so then we get our greatest common factor, negative 4d, times d minus 2. That's our first one. And then you notice that it's exactly the same, right? And because of that, we can take d squared plus 3. As our next. So this would be your answer. So you can kind of combine the two sets. When I look at this, I can see that 3 and p go into all of them. So I have 3p times 2p to the third power plus p to the second power. Whoops, that's minus. Minus 8p minus 4. Now I can split them. And so I'm going to get 2p to the third power plus p squared minus 8p minus 4. Looks like p squared. 2p to the first power plus 1 of 4 2p minus or plus 1. So then I get 3p times 2p plus 1. See how they're the same? Times p squared minus 4. And that gives us our final answer. Okay? You choose the method. This is just a way of breaking it down into smaller sections. When you have one like this, remember that if you cannot find a greatest common factor, then it's going to be prime. Don't forget. If you have any questions, make sure you contact me. Thanks.